Good morning, everyone. Thank you for joining and welcome to today's webinar. My name is Katrina Ryan. I am TriStar's Mid-Atlantic representative. Today I am joined by Paul Sagar, Paul Dye, and Brittany Woods from PTC, who will be presenting on Creo topics. Before we get started, I wanted to go over a couple housekeeping items. First, a complimentary recording of this webinar will automatically be sent to everyone who registered. Additionally, the recording will be available on our website and YouTube channel shortly after the presentation. If you have any questions during the presentation, please feel free to leave them in the chat. At the end of the presentation, we will hold a brief Q&A session. Before I pass it over, I did want to briefly introduce TriStar for anyone who is not familiar with us. As experts in CAD, data management, PLM, and product development, we, TriStar, specialize in helping manufacturing companies adopt systems and processes to enable better and more efficient product development. In addition to being the largest value-added reseller of PTC products and services worldwide, we also have a large assortment of custom solutions, services, and support packages tailored to specific requirements and needs. We've been in business for over 25 years, headquartered in Phoenix, Arizona, with representatives and engineers throughout North America, Canada, and Mexico. Now, I would like to introduce Paul Sagar, PTC's Vice President of Creo Product Management, who will be sharing more information on PTC's vision for Creo.
Thank you very much. So good morning, everybody. I'm just trying to find where the share button is. Now I have it. Okay, great. So hopefully everybody can see my screen now. So my name is Paul Sagar. I run the CAD Creo product management team here at PTC. So I'm responsible for defining the future direction strategy that we take with our Creo set of capabilities and products. What I want to do is spend maybe 10 minutes or so just talking about what our strategy is, how what we use to inform our strategy, and at a high level, directionally where we head with the product. Before I'll hand over and you'll start and see the fruit of that strategy and a number of enhancements that we've added in Creo 9 and beyond. So to begin with, when we start to see where we want to take the Creo set of capabilities, we start by taking a deep look into what is happening in the market. And what we see right now in the market is really three trends or disruptions that are common across most of our customers. And those are things such as worker shortage. What we're seeing is, excuse me, even though, let's say, a similar number of people are going in and getting engineering qualifications, what we're finding is when those people come out of university, fewer of them are actually going into engineering jobs or manufacturing jobs. More of them are taking their engineering qualifications and going into business or finance or analytic type roles. And so that means there's fewer people or a smaller pool of people to choose from coming into businesses. Conversely, on the opposite end of the spectrum, you've got a lot of companies that have an aging workforce, and a lot of those people are approaching retirement age. They have a lot of knowledge and IP tied up in their brains, but they're about to leave the company. So you've got fewer people coming in at the bottom end, and you've got more people leaving at the top end. Overall, your workforce pool is shrinking. Secondly, there are some risks and pressures around costing, around supply chain. We certainly saw a lot of supply chain issues over COVID, where products, supplies just couldn't be delivered out to the OEMs. And then finally is the let's say, trend and a potential disruption that the digitalization has on industry. And this last one is a little bit of a strange one, because companies are a lot of companies are looking to go through a digital transformation, looking to take advantage of what's called the digital thread throughout their business. So how can this really be classified as a disruption as well, when many companies are looking at it as a the future of their business and how they're going to transform their business? Well, the reason it is a disruption here comes down to the size of the business, size and age of the business that you're talking about. If you're a company that has been around for 100 years, you've got a lot of history, a lot of processes, a lot of knowledge tied up in your business. And to transform that business is going to be a very long, time-consuming task. Conversely, if you're a new company or potentially a startup company, you can define whatever processes, workflows, strategies you want very easily, and you've got no legacy to manage. So you're able to define your business from the beginning with a digital backbone, with the notion of a digital thread throughout your entire enterprise. So that puts at risk the fact that older companies potentially could be leapfrogged by younger, newer companies. So those are the three main trends that we're seeing. And so what does that equate to when we look at engineering? Well, what it really means is companies out there need to find a means to really drive innovation. They need to be able to find a way to clearly differentiate themselves from their competitors, so that the products that they are producing are products that are always going to be at the top of the market. Converse or equally, they need to find a way to close that skill gap. They need to find a way to democratize that IP, the expertise that those subject matter experts have, and democratize it so it's easily accessible to the broader organization, enabling them to fundamentally do more work more efficiently with fewer resources. And then the final one is accelerating and getting to market quicker, right? It's with the fluidity of the market, you have to be able to be more reactive, and you have to be able to make sure that you can get your product to market faster. And so along these lines, we have capabilities in Creo that go and address different aspects of this. So as an example, closing the skill gap, democratizing IP, you would look at capabilities such as generative design that can offload a lot of the work that an engineer typically would do, and offload that work to the computer to go and generate the optimal design. From the standpoint of accelerating time to market, you would look at things like simulation-driven design. How can I get my product to market earlier? How can I design my product quicker? How can I get to the point where my product works first time as I've designed it? And you do that by bringing simulation earlier on in the design process. So when you're concepting your work or doing your initial concepts, simulation is part of that process. So overall, what is Creo? And so Creo, as many of you here know, is a full 3D CAD system covering all areas from early stage concepting, full detailed design, into manufacturing, covering areas such as advanced surfacing, such as simulation, such as full 5-axis manufacturing, additive manufacturing capabilities as well. And so with every release, we always focus heavily upon improving this broad set of capabilities across the entire breadth of the product. So focusing upon making the end users more productive on a daily basis, whether that is refining certain workflows, making tools easier to use, or adding additional capability to the product, but really focusing on making every engineer more productive on a day-to-day basis. Now, in addition to that, what we also see, though, in the market is there are a number of emerging technologies that exist out there or are starting to bubble up to the top out there. And this was a report done by Deloitte a few years ago, but there are similar reports from other companies. And this just highlights a number of emerging technologies out there and some of them are relevant to the manufacturing industry. In actual fact, over half of them are relevant to the manufacturing industry. So emerging technologies such as 3D printing, such as analytics, such as simulation, such as high performance computing. And so we look at these emerging technologies on an ongoing basis and figure out which are relevant to manufacturing, which are relevant to CAD per se, and start integrating those technologies into Creo, but integrating them in a way where they work in exactly the same way as any other capability does in Creo. So they're not a separate standalone technology that results in a broken tool chain. They are part of the design process. They are fully integrated into Creo. They look and behave exactly like a Creo application. And so whether you're looking at things such as real-time simulation, where you're able to do structural, modal, thermal, even fluid simulation in real time on your inside Creo as you're designing your product. Capabilities such as generative design, where you can provide a set of constraints to the system and have Creo go and design the optimal product for you to meet those engineering requirements. Whether you're looking at IoT-driven design, there are many companies out there that build products that have sensors on them. If they're able to understand that sensor data and feed that sensor data back into their CAD system, they can use that to better understand how their product is being used in the field. It can be used to better understand root cause of a potential failure in the field and leverage that to improve their next generation of designs. Also, augmented reality, being able to easily share a design with a colleague or with a supplier, being able to get a full-size representation, view, and understanding of the design that you're working on without losing or sharing any particular IP gives you greater clarity on the design that you're working on. And finally, additive manufacturing, as more and more companies are looking into additive manufacturing, not just for rapid prototyping, but for final part production. There you need to start looking at not just how do I print it, but how do I design it as well. For years, there's been dedicated capabilities inside Creo and other CAD systems for designing sheet metal components or injection molded components, but not for designing additive manufactured components. So being able to build complex lattice structures, being able to build heat exchangers that take advantage of complex lattice geometry. All of this capability built entirely and fully integrated into Creo. So hopefully that has given you a quick high-level overview of what the strategy is with Creo. So twofold: focus on expanding and making the core set of Creo capabilities easier to use, making the everyday user more productive, but at the same time focus on understanding, leveraging, and integrating emerging technologies into the Creo set of tools, making sure that Creo remains at the forefront of innovation and engineering. So thank you very much for your time, and I'm not sure who I'm handing it back to.
That would be the other Paul on the line. All right. And can you hear me okay, Katrina? Can you confirm you can hear me? I'll go ahead and share up my screen.
Sounding good.
Well, awesome. All right, and let me know whenever you can see my screen.
Looks good, Paul.
Awesome. Well, thank you first and foremost, Paul, for the introduction into where we're going here with Creo. There's so many different exciting areas that I'm very happy to get on and kind of expand upon some of the things that Paul Sagar has gone through and talked to. There's so many different areas that we're working on and constantly improving in Creo, and it's definitely something exciting that I'll be able to walk through. And thank you, TriStar, for having me on. It's great to go through and really spread awareness around some of these different tools. A lot of people who aren't even aware of the full breadth of what Creo can do, and maybe even some of the things that they already have access to. And if you don't, it's definitely something that I'm more than happy to go through and walk through what some of these different things look like from the context of Creo. And I want to reiterate for anyone that's online, if you have any questions, if you have anything that Paul Sagar went through that you have questions on that you want us to expand upon, or anything as I go through what I have to show today, feel free to drop that in the chat and we can definitely get to any of that. So what I'm going to really do and how I'm going to structure this is essentially I'm going to walk through some of the different main areas that we focused on with some of the more recent releases of Creo and some of the different areas that we've really put a lot of time and effort and honestly money into to really build up and expand upon from within the context of Creo. And then I'll go through and show some quick demonstrations that allow you to see what these different things look like from the context of Creo. All right, so starting into it, one of the biggest areas that we always really have a focus on is just the everyday engineer. So there's so much that we do around different emerging technologies and new fields, new manufacturing techniques, new design techniques. But at the same time, we also want to put a focus back on your everyday Creo designer. This is still a very large portion of our user base. So we want to make sure, first and foremost, the tools that we use for 2D sketches, for 3D models, for these types of features, we want to make what you're doing in each of those facets as efficient as possible, and really making sure that from a UI perspective and from a capability perspective, we're making you efficient on a day-to-day basis. And then we have specific areas that we've really enhanced in this sense as well. And I picked a very creepy image to go through and show what this looks like, but we're really able to go through and kind of shift gears from what you may have already thought of in terms of surfacing, where you might think, well, in Creo, we have really strong parametric surfacing techniques, but we also have a lot of overlap into what you might consider more free-form modeling, where you have more organic shapes as well that might want to play into more of your parametric designs. So we've put a lot of time and effort into our surfacing tools, things like our free-form modeling, for giving you the ability to go through and build out more of these organic shapes. And it could be building out something like this where you really do want to get more of a lifelike figure, or it could just simply be you have some parametric models and you want a clean organic shape that's going to flow between one part to the other. So we've done a lot of work in this sense to go through and give users the ability to create this type of freeform geometry in a way that's easy to use and in the same environment of what you've done everything else from within the context of Creo. And that's a big thing that you'll see kind of overall with what I'm going to go through today, is everything that I'm doing and every different tool that I'm going to go through and show today, it's all within the same user interface. So if you're already using Creo Parametric and you're using your standard design tools, you're already going to be halfway there to learning how to work with some of these more emerging technologies. We're not going to introduce a capability and make you learn a new system in order to work with it. That's part of the beauty of this all, is the fact that we're able to use all of this new technology and a lot of this emerging tech, but do it in an environment that you're already used to and very strong at working with already. Even tools like human factors and ergonomics. In so many different industries, this is a hugely important area where it's not just making sure that our products work, it's how do they work for the everyday user? How do we take into account the people that are working with this, our demographics, and working from the low scale of that all the way up to the high scale? We want to make sure that we're making our products work for all of those different demographics. So we have tools specifically in Creo that allow you to do that type of human factor and ergonomic analysis, make sure that your users are able to reach certain things, that they're able to see what they need to, and at the end of the day, everything is being done in the most ergonomic way possible. And if it's not, then you want to have access into that, be able to see that and be able to make changes to that before something gets sent out to the field and before it's out into action. We also have a lot of enhancements, like Paul mentioned earlier, in the area of manufacturing, and it's something that we've had incorporated into Creo for a long time now. It's essentially always been a part of what we do from the context of Creo, and really that's why I always say that it's less a 3D modeling tool and more so a product development suite of tools, because it's more than just building out our 3D models. We want to expand into essentially every area of the design process, and one of the big areas for that is manufacturing. We see people that build out designs for casting, for molds, for everything from extrusions, mills, lathes, additive manufacturing. It's all these different areas that you can think of. We essentially don't want to limit you in terms of how you're going to build out a design. So the idea going forward is essentially go through and build out the model in the way that you think is best, and you don't have to take into account a lot of what you're doing for manufacturing, but simply just build up your designs, and then we have tools that are able to account for specific types of geometry. So first and foremost, we've always done a lot of work in the area of subtractive manufacturing, things like three-axis mills and lathes to go through and build out from a stock piece of material, but we're also starting to support a lot more enhancements around that area. We see some very complex machinery, things like 5-axis mills, where we're able to get to more complex geometry from just a single stock piece and being able to automate that process. Even combinations of mills and lathes, for example. A lot of people do live tooling where you're combining both of those two technologies. So we're able to support a lot of those different enhancements now going forward in the context of our Creo designs, go through and get these things built out, put them onto any level of manufacturing that you need to do over on the subtractive side. And then a huge area that we work with here from within the context of Creo is also into the area of additive. This is another area that we've put a lot of time and effort specifically into our additive manufacturing extensions in Creo to really give you all the functionality that you need to build out designs with truthfully an entirely new world of capabilities in mind. One of the biggest areas that we've had to focus on, and something that I'll actually go through and show in my demonstrations today, is in the area of creating lattices. Lattices in general are giving you the ability to create very strong, robust geometry, but at the same time saving on things like material costs or even just making a design more visually appealing. It's in general something that simply wouldn't be possible to create using your more standard types of manufacturing techniques. But for a 3D printer, it's a piece of cake, not only to first and foremost design and automate in Creo, but also to create out on that 3D printer. And you'll see that there's many different types and configurations that you can build out in Creo, from more 2.5D shaped lattices to full 3D formula-based lattices where we're able to cut out the use of support materials. It's still able to go through and give you a design that's structurally sound, but able to really be efficient and optimized for the things that you care about. You can take out weight and still maintain the structural stability of your models. And with anything that we do from a manufacturing perspective, we have a strong integration into our different optimization, analysis tools, design tools, even into integrating with those machines from the direct interface of Creo. So for example, we have interfaces with companies like Materialize and iMagics where we're able to connect directly to 3D printers right from within the same interface as anything else that you're doing in Creo Parametric. I'll be able to go through and show a little bit about what that process looks like as well. But essentially, our ability to go through and give you one single environment to do that level of design all the way down to manufacturing is something that we have a big focus on, and we definitely are going to keep building out going forward. And then another area that you've probably seen into in the past is the idea of model-based definition. So traditionally, we've really seen the process tends to be you go through and build out a part, and then you take that and you build out a 2D drawing that you would send out for your manufacturing, whatever that might be. Now, the idea is that going forward, we really want to support a lot of the work that we're doing that we would typically put onto a 2D drawing to send out for manufacturing. We're able to do that right on the model itself. So whether it's a part or whether it's an assembly model, be able to take everything that you would normally go through and do for your dimensioning and your tolerancing and building everything out that you need for the manufacturing side, and just do that right on the model itself. So that first and foremost is going to make you more efficient in the way that you're working. You can go through and do more simultaneous work in the sense of where you're building out the models, and at the same time we're able to lay out a lot of that geometric dimensioning and tolerancing that we need later on down the line. And secondly, I'd say probably the biggest benefit to doing any type of model-based definition is just the clarity that you're getting from these models. It's no longer you're going through and having to try to interpret this large-scale drawing where it's hard to even understand what a certain line or what a dimension or tolerance is referencing. We can really go through, lay this out from a much more functional standpoint, give users down the road, all the way down to manufacturing, the ability to pull up these models, see them from different views, and much more clearly understand the work that needs to be done on them and understand everything that's associated with that model in terms of how we need to go through and get it built out. So going forward, we're going to, with every single release of Creo that you're going to see going forward, just put a ton of time and effort into making sure that our users that are looking to do more work from the model-based side of things are going to be supported, and that you're going to be able to do really both going forward, whether or not you're doing things from a 2D base on your drawings. We're not going to stop supporting that anytime soon, right? That's definitely something that we still are going to keep making improvements to as well. But anyone that's looking to do this from a model-based definition standpoint, from a detailing standpoint on the models themselves, we're going to support a lot of that work that you're looking to do. All right, and what I can go through now and do is show a couple different examples of what it looks like to use some of these different tools from within the context of Creo. I'll first and foremost go through and show an example of what it looks like to do some of that human factor and ergonomic analysis. And I could take a step over and show some of our more traditional manufacturing that we've gone through and built up, some of the different enhancements that we've had over there, and then even into our surfacing capabilities. I can walk through that as well. In a later portion of the demonstration, I'm going to go through and show a few different areas around analysis and what we might do for additive, but I'm going to go through first and foremost and just show what some of these more standard techniques and some of these more traditional enhancements that we have, still emerging technology, but more so for just the everyday engineer and designer. So let me go ahead and switch over now, and we can just jump right into it. Right, so first and foremost, let's start with some of the surfacing work that we've done from within the context of Creo. Go ahead and show you what we've done with our freestyle tool. All right, so now we're here within the context of Creo, and I'm going to be opening up a part that we want to use for our freestyle design. And more specifically, first and foremost, what I want to dive into here is some of the new brush capabilities that we have available to us, which I'll show in a couple different examples. So you can see here that this rabbit actually was created using what we call reconstruct from facets feature in the freestyle. So this could be a model that was simply sent over to us from another system, but actually from within the context of Creo, it could also be a model that we use a 3D scanner to pull up and bring now into our context. So that's something that we could go through and work with and still use in, for example, in our concept design phase. And with this, we have different options to change the resolution here to give us a little bit more control if we'd like to. And then up from the rim and up at the top, we'll go ahead and open up the brush tool, and you'll see that we have a few different options here. The first option would be to pull, which is going to move our mesh vertices along their normals. And this brush size has a lot of different settings that we can change to increase or decrease the detail and the size that we're able to go through and change with that. Even options around the softness and the intensity to really give you some more organic looking surfaces, and these can always be changed while you're working. And once you have everything set how you want it, you can take your brush and go through and start to do some manipulation here on the mesh. And you'll see that as I move the mouse along that surface, it's pulling on the different facets to give us different types of geometry. And one quick thing that you could do is hold in the shift key, which will essentially allow you now to push that geometry in the opposite direction. And then from here, inflate is another brush option that we have to more uniformly scale that mesh. This could be useful for one of our rabbit ears, for example. Go ahead and try that out here. And one other useful tip for the brush is the fact that it could also be used just for general selection on the model. So this is a very quick way to go through and select on the faces of that surface. Go through and get some of these different areas of the mesh. And once you have that selection, it's just as easy to go through and jump back up into your different brush tools to make your proper adjustments there as well, whatever you might need to do in that sense. All right, so just a quick look there at some of the different options that we have around our freestyle tool. So again, want to support what we're doing on both the parametric side and some of the surfacing work that we do from that sense, but also for our users that are starting to work more into the organic world and wanting more of these freeform style shapes. We have a lot of capabilities in that sense as well. All right, from here, we'll switch gears and talk a little bit more into some of the human factor capabilities. This is also, for some users, you might know this as Manikin. So depending on the different types of designs that you're working with, you have a lot of different considerations that you probably have to take into account. Fit, ergonomics, obviously something like this, like a motorcycle, these different types of things are going to come into play. And that's what human factors is all about. We're able to bring in these types of human models and make sure that they can see what they need to, make sure they can reach, make sure they fit. And going forward, we're introducing a lot of new functionality around this. One of the biggest ones is the ability to create custom mannequins. We have a huge library of standard size people, tall, short, various ethnic backgrounds. And what we're able to do now is take that and customize it. We can make them however we want, taller, shorter, heavier, longer or shorter arms, whatever best fits the demographic that we're designing around. If you're going for a specific market or you have certain limits, you can go through and build that out on your own. And you can see it's a very easy to use interface here. So set the height, the weight, different components. And then you can take these and use them in any of your standard human factor analyses that you want to run. So set these up exactly the way that you want, change the chest size, the waist height, lots of different attributes that you can work with. And once you have it how you like, you can go ahead and save that off. This will be an inseparable assembly. So it's very clean, easy to work with inside of our other assemblies. And now that's something that's completely customizable. And what I'll do now is go back into our model and add him in. Make sure that he's going to fit correctly. We'll just jump right up here into Manikin and insert him into the design. More specifically, let's grab the custom mannequin that we were working on, and we want to place him onto the bike in a seated position. So a couple different references that we can lay out for that, where we want to place him, what direction he's facing in. Essentially going to be a datum plane or a surface from his bottom side and a direction to face him. And once he's situated in there, we can work with our new interface of changing things around. So over on the left, what we have now is first and foremost a mannequin tree that we can manage all the different pieces and snapshots in time. How this works is we can put the mannequin into different postures, hands in the right positions, take snapshots of that. And we also want to make sure that he's able to reach what he needs to, make sure that he's able to use this functionally. And what we have is a new reach feature built out here that if your mannequin would be unable to reach, what it's going to do is put the arm out as far as possible so you can see exactly how close you are and see exactly what that distance is. In my case, seems to be working pretty well for the right hand. And we can put our other left hand in there as well. We can use our new dragger functionality, make it easy to adjust, make sure that it's comfortable, for example. And from there, we can manipulate him, change the forearm position, use that 3D dragger to move the arm, make sure that everything's working as it should. And you might want to do something similar also with the feet on our design once our hands are all good. And that's the way this works, is we're aligning different points in the model with different points in the mannequin. It's fundamentally how that reach feature works, but it's going to work with the other limbs as well. We can do the same thing on the other side here as well. Just make sure that these motions can physically be done, but at the same time, making sure that we're not going to have problems. If the leg were to be interfering with the muffler or bumping into something with your toes, it's much better to figure that out here rather than having to go through and build out a full-scale prototype. All right, and maybe we notice that our model here looks a little bit uncomfortable. What we can do is go through and make some changes if need be. We can use that from our mannequin tree on the left if we want to. We use the dragger to move him into the right positions, try to make his riding experience as comfortable as possible. And these are so easy to go through and build out in Creo going forward. All right, I think he's looking pretty good. Manikin's just about good to ride, get on the road. And that's just an example of what we can do there. This has a ton of different capabilities and a lot of different things that'll work for so many different industries out in the world. All right, let's go ahead and move on from there. I want to touch a little bit more so now onto the side of, I'll say, analysis and how we look to improve what we do from an optimization standpoint. So one of the biggest things that you've probably seen, and something that's been really a huge ticket item from within the context of Creo for a few different releases now, is our partnership with Ansys. This was a no-brainer for us to start to integrate what they have in their different tools and their market-leading technology right into the Creo Parametric environment. So this is done in a number of different ways, and the first way that we started to build this out was with a tool called Creo Simulation Live. The idea is that we wanted to break down the wall between two different worlds of design and simulation and work more in one unified modeling and analysis environment. Our way of doing that in the world of Creo was with our Simulation Live extension. So this was the first tool that we built out through our partnership with Ansys for embedding their Discovery Live simulation engine directly into Creo Parametric. It uses a very powerful linear solver, gives us the ability to do multiple different types of simulation, from structural, thermal, vibrations, fluid types of analysis. And one of the biggest areas that this helps us with is the fact that normally designers don't have a lot of experience around analysis. They aren't very experienced with doing defeaturing work, building out meshes. But one of the greatest things about a tool like Simulation Live is we don't have to do any of that. It's a meshless environment. We're removing the need to go through and create a mesh on the model, and the analysis that we're doing is instantaneous. That means when we make changes to the part, changes to the materials that we're using, even changes to the analysis definition itself, it's all able to automatically update for these things and give you those results back very quickly. So an extremely powerful design tool that we have from the early to mid stages of the design process, and something that our designers and engineers are going to get a lot of great use out of. Now, going forward with this, the second tool that we built out through that partnership with ANSYS is called Creo ANSYS Simulation. This is a more comprehensive tool for doing your linear or static analysis, same areas for structural, thermal, and vibrations, but this is getting a little bit further along in the process now, whereas a tool like Simulation Live is helping you to do design work earlier on in the process, this is now helping you as you start to get more towards that validation style analysis, where we want to understand how our models are going to be performing whenever it's time to send them out for manufacturing or prototyping, and go through and do, I'll say, more of that validation style analysis, where we want to make sure that our models are going to be good to go whenever it's time to get them built out. And this is still a very easy environment for setting up different studies. All the loads and the constraints that you're laying out here that we pulled over from ANSYS are still going to work well. This is good for a designer or engineer. But at the end of the day, it's still using that extremely powerful, proven technology that we have from ANSYS to give our users the confidence to make sure that the designs that they built out are not going to have issues whenever they send them out into the real world, and make sure that we're really sending out the best models possible. Along the same idea here, we also have a lot of strong capabilities within our flow analysis tools from within Creo. This is a tool that we have built out through one of our partners, Simerics, to put fluid simulation capabilities still into the hands of our engineers and designers. It's normally a tool that requires extensive knowledge, experience, and truthfully a lot of money to go through and try to get some of these studies built out in other areas of the industry. But within Creo, it's something that we give to all of our designers and are constantly making improvements to. We are really on the cutting edge for a lot of this fluid simulation capabilities that we're building out. So many different areas that you're able to go through and simulate for your fluid tiles analysis, whether it's internal flows, external flows, even if you wanted to do some level of optimization from within Creo and tie that in with your fluid dynamics capabilities, that's something that we're able to do. And another area that we're just constantly making improvements to. So if you haven't seen any of the new areas that we've built out into flow analysis, it's definitely something that you're going to want to check out. I can also go through today and show you some of the new capabilities that we built out and some of the new interface of what exactly that looks like from the context of Creo if you haven't seen that before. And then the area of generative design is a huge ticket item that we have now from within Creo. If you haven't seen this, this is essentially our tool for autonomously creating optimal designs from a set of system design requirements that you have. Say, for example, you have certain loads or constraints or preferred materials that you want to work with, or manufacturing processes, and you don't know exactly how you want to go through and build out that model. Well, that's where generative is extremely powerful. It's something that we're able to go through and create these optimal designs without you having to go through and understand exactly how you want to build out that geometry. Just let Creo do this work for you. So this is a tool that we call Generative Topology Optimization, or GTO, where we're laying out these different goals and requirements, and then the system will go through and generate those designs that you or I, as human beings, probably would never have thought of, but we can use these either as a design as a base for a product that we want to further refine upon, or even just as a means of concept generation for other designs going forward. And you can run as many of these as you want. We don't want to find a design that simply just works. We want to be able to build out these designs with all those different design goals and manufacturing constraints in mind, and go through and work with this much earlier on in the process and start to do that level of optimization without those pre-existing biases that we typically have. Now, one of the areas that we're able to take advantage of here is what we call cloud-based computing. This is utilizing our full generative design extension, where we're taking all the functionality that we have in our topology optimization, and now we're going to be utilizing the cloud to enhance our abilities and really take that generative design to the next level. And getting started is a seamless process. There's no licenses or software to install. You just have a direct connection from Creo right up to the cloud. So with one click, you essentially take everything that you build out into a study, send it up to the cloud, and then you're utilizing high performance computing in that cloud to set up so many different studies and allow you to go through and just click one button to generate, and your generative design tool will do the rest. And once the designs have been generated, you're able to go through, compare them, display different results, and then ultimately bring something back in your design that is optimized for all the different things that you care about, and ultimately probably give you lots of different design variations to work with. All right, from here I can go through and show a couple of examples of what some of these different areas look like. So first and foremost, I want to show you a quick peek into what we have for our Simerics tool from the fluid simulation side of things. Then I'm going to switch over and then show what it looks like to do some generative design, as well as latticing, and even into the areas of 3D printing and AR. There's a few different areas I want to go through and walk through here. So without further ado, we can go ahead and switch over into that. And again, if you have any questions, feel free to drop those in the chat as well at any point while we're going through here. All right, so we're going to go ahead and dive into a quick flow analysis demonstration. And in this case, what I'm going to go through and do is show our integration with what we can do from our behavior modeling studies. So in this case, we're looking at the front of our design. We've got a windscreen, got the dash, got the beak down at the bottom. And with this, I have a few different initial conditions set up. But if you haven't seen this tool before, we're essentially doing these sort of flow analysis studies right from within Creo to look at many different types of fluid simulations. In this case, it's going to be an external flow, but this is very easy to work with, very easy to see and visualize the different results from the study. You can very easily change around what you're looking at with these pop-up toolbars to get everything that you need right in front of you without having to track down various menus. So in our case here, you'll see that the front of the flow is entering in at 60 miles per hour, and these are the pressures. You can see the results that we're getting from there. And that's pretty good, but say that you want to improve upon that, get better results in some way, or even see if the design can give me the minimum results that I need, what I'll do is set up a behavior modeling study. So what this now becomes is an input parameter that I can use with other variables in my design, such as pressure, and helps us to answer certain questions. Say, what speed will we be getting to see that pressure that we're concerned about? Maybe we need to stay under a certain pressure, and that's really what these behavior modeling studies in our flow analysis give us the ability to simulate. So instead of us having to manually try out different design variables and design parameters, we can instead let Creo do that work for us and see what we get. So first thing that we're running here is a sensitivity study. So if I vary a parameter or a value, what type of results are we going to get? In this case, for pressure values. So it's a lot faster than us having to go through, try and iterate through values to see what we get. We can instead just let Creo go through, compute that for us, see what we get, and we can see that all plotted out. And even better now, what we're able to do is an optimization. So this is another study that we can use to get to our most optimized model. So this is normal Creo functionality, but now we can go through and directly make use of that here in our flow analysis study. So in this case, maybe set the pressure on the part to certain values. That would be my design constraint. And then we can say what we're allowing the system to vary. So we can allow that velocity to change here. And what's great about this is the fact that we could run multiple different parameters or constraints, 4 different variables, and just let the system run. If the constraints that we're looking to get to are impossible, the system would let us know. But it's a lot better than us having to fumble around for a day trying to figure that out. So we can instead let that run through, see what value it converges to for our optimal result based on however many iterations that we give the system to run through. And then once the system converges, we're able to see exactly what that value will be. And it's something that we can automatically have applied to the study once we get that value. And then once you have that change, you're able to run back through here and get the new results for the study. So really working to understand what that more optimized model is going to look like, and doing this type of more refinement work throughout our flow analysis studies, not only getting to a design in a study that simply just works, but really getting to a much more refined and much more efficient model at the end of the day. All right, there we go. So quick look into that type of study here. And what I want to switch now into is another study that's going to go through and show a lot of different examples. So this will almost be like a tasting platter for some of the different areas of Creo that I haven't hit up on until this point, and really show how these can all go through and integrate with one another. So let's go ahead and take the last 10 minutes or so of our webinar today, and I want to go through and show a few different areas on our lawnmower assembly. And specifically, let's go ahead and get a part off of the mechanism located on the right-hand side here. All right, and you can see here, this might be a part that's in active development that we're working on right now, but we want to see if we can improve on the design or maybe just simply reduce the weight of the part. So what we can do is utilize our generative engine for that. So again, this process is autonomously creating optimal models from our different set of system design requirements that we have. Could be manufacturing processes, materials. So we can focus on many of these if we'd like to, many different materials, lay out all the manufacturing techniques that you and your team have available to you. And you could run each of those one by one right from within Creo, or what we could do now is take advantage of our cloud computing to run all these different considerations in parallel. So we're able to use this cloud platform to simultaneously calculate all the possible study solutions here for different material parameters, manufacturing processes, all using this high performance cloud computing. And what you'll see is that we're actually working just right from within Creo using the embedded browser. What we've done is upload our complete study setup containing the different design requirements and criteria that we have. And in this case here, Generative Design saw that we might have made a change to the study that we were working with. So we can go ahead over into our setup and add in that stainless steel alloy. And once we generate that, we're brought into the Design tab. So this is where we can go through and look at the results for each of our runs, begin to filter through the data to see exactly what we're working with here. And we can also monitor the progress of our current design study as it's being run. And once it finishes up, we can start to filter through the data to focus in on a particular design. So we can do this by selecting on different design criteria. You can focus in on particular materials to see how they performed. You can select on a few of those runs and then compare how each of the materials did against one another. And the graphs that you're looking at here are all very interactive. You can flip the axes. You can even select on particular ranges that you want to work with to filter out any of the designs that don't fit, say within a particular safety factor. We could do the same things for stress values, mass, and as it's doing that, the amount of designs that are going to pass through is being lowered down, just ensuring that we're only getting the best possible designs going forward. And you can also see graphically up in the top right-hand corner how each of these designs stack up against one another. You can go ahead and change any of those axes to prioritize what's most important to us. Makes it a lot clearer to go through and select on only the designs that do well on multiple factors, say like lowering mass, keeping max displacement down, or even focusing in on a highest safety factor. And once we've been able to narrow that down, we can do a direct comparison between each of them. So we can see each of the designs side by side, display values like von Mises stresses, see what we're getting in that sense. You can also take a look at the displacement that we're getting, even get a better understanding of that by animating on the deformation that we're seeing. And you can see whenever I move one of those views, the others are going to update as well. And from this point, we can go ahead and share the designs with our team, get some feedback, and then ultimately select one that we'd like to bring back here into Creo. And we're able to take that design and back in Generative, choose to generate a full B-rep or boundary representation, which we can see here Creo does very quickly. It's all been built out using that optimized geometry using the freestyle feature, which you saw earlier, and all integrated back in with our initial geometry that we started with. And once we have that geometry, we're able to take it a step further and do some real-time simulation, again, using Creo Simulation Live, like I mentioned earlier. So it's taken all those loads and constraints that we had laid out in Generative, carried them over here into the model, and you can see we're able to get that instantaneous feedback from Simulation Live to see more detailed values into the von Mises stresses, see exactly where our problem spots might be, where we're getting maximums or minimums. Take a look at our deformation, see if our part is responding how it should be based on the loads and the constraints that we had set up. So Simulation Live or CSL is greatly benefiting our different designers and engineers. Maybe they don't have the experience and training needed to run full-scale analysis, which oftentimes can be very time-consuming. But with CSL, you don't need any of that. You don't have to spend time waiting around for results. We essentially just click a button and get those results back instantly. And so once we have that all built out, we can go ahead and swap that back in, and we're good to keep moving forward from here. Here's another part that we're working with. This is something that's probably also in the early stages of development, which is a great time for us to get that feedback from our analysis to see exactly where we're at and see potentially where we might be having problems down the line, or where we could start to make improvements to the model and really start to work towards more of an optimized design model overall. And again, Simulation Live, you immediately get access to those results. You can see where we're getting the highest amount of stress in the model. Right now here, it's at a pretty critical point in the design. So what we need to do is find a way to more evenly distribute stress throughout the model. We can quickly check in on that deformation, make sure that our model is working how we intend it to. And what we can do now is actually export some of those results that we got throughout the model from our analysis and use that to drive the different features that we're using here in the model. So more specifically, what I'm going to be doing here is using those results to drive a variable density lattice. This is taking the results that we got from our simulation, and we're going to thicken that lattice where we need support and then decrease the lattice density where it isn't needed. It's helping to distribute stress throughout the model, especially away from more of those critical areas. And you'll see that setting up lattices, it's very straightforward. You just say which areas that you'd like to replace in the model with a lattice. And then from there, you have lots of options when it comes to the shape and the size of the lattice cell. Go through and lay that out for you. And after that, you have lots of different options for the structure, really getting that lattice to fit how we want it to look, how we want it to function. Go through and change that as needed. And then finally, what we're going to do here is drive the density of the lattice based on the results that we got back from our analysis. And this is really what I mean whenever I say analysis-driven design. We're using analysis to not only validate that the design has been built out correctly, but also right from the beginning stages to drive the function of the model and then ultimately give us a model that's going to work better in the long run. So you can see here, even though you have some fairly complex geometry, you're able to simply reconstruct that feature very quickly and just as fast, jump right back into the simulation to see the effect from that new variable density lattice. And looking at this, you can clearly see that we have a much more uniform stress distribution, and even more importantly, we're able to move that stress away from a critical area of the model. That's a huge plus. And looking here also into our deformation, we can see where we're getting there. And it's looking to stay about the same as it was before, but we're able to change that around and change this, and probably also change how much material that we use in order to get here. So not only able to distribute the stress better, but also save on weight of the part. And these are all things that were only possible due to all the different manufacturing capabilities that we have here in Creo. And there's a lot more that goes into additive design in Creo, but I'll touch more on that in a minute. Now, obviously, there's a lot of different changes that we made up until this point, probably things that we want to share off with people on our team to get some feedback. And one of the best ways that we have of doing this in Creo is using augmented reality. This is going to take the model that we're working with here in Creo and share it off with others, where they're able to view the model right in their own physical space, on their desk, in their office. So that's what I'm doing here, is first and foremost creating a spatial target, which will essentially act like the floor for the model. So whenever the end user is going to pull up this model, they're able to project it into that workspace that they want to view the model. And this is completely changing the game for how we do things like design reviews, build out virtual prototypes. Is transforming how companies are designing, producing, supporting, and also even selling their products at the end of the day. Right, so here we're just simply creating a QR code that we can take and send to whoever we want to view the model. And then now, once we have that sent out, we can switch over into what they would see from their view, where they're able to pull that model up and view it right on their desk. They're able to rotate, scale, even look at the different combination states from within their experience. It's way better than just simply getting a screenshot to share off with somebody's workstation. All right, now taking what we've had here, once we've had the chance to review it, we've decided that we'd like to move forward with a certain piece of the design. So first, what we want to do is get a prototype built out using a 3D printer. So let's go ahead first and isolate the part that we're interested in. And from here, we have a lot of functionality to do this work from right within Creo. First thing that I want to do here is what we call a build direction analysis. This is going to allow us to determine the optimal printing orientation for the model. It'll take into account things like our critical and subcritical angles, which determines the amount of support material that we need. And that's what we ultimately want to optimize around. We want to decrease the amount of support material required, cut down on the printing time, and even take into account the removal of our support material in the post-processing phase. This is very quick to do. We can see that the system goes through multiple different iterations until we converge upon a solution. And once it's converged, we can check out the result that we got. And once that optimization has been complete, we have a new orientation to print from. So we can take that model now and arrange it onto our 3D print tray, which again, we can do right from within Creo. What we can do here is optimize the tray to fit many different parts on the tray if we'd like to. We can also do what we call a printability validation to check our model against the thin wall threshold to make sure that our model isn't going to have any issues in that regard. So we can just simply let that run through. And in our case, we don't seem to be having any issues. And once we confirm that our model is good to go, we can go through and generate our support structure within the same environment. There's a lot of different parameters that we're able to go through and change here to better represent the printer that we're going to be using out in the real world. So we can set up our different support profiles to focus in on that support type, the angle that our printer requires supports at, and a lot of other parameters to best build out our support structure for that model. So we'll go ahead and let the system build out that support structure, which Creo actually builds out as a PRT file that we can work with and manage going forward if we'd like to. And from here, we could review that support structure and then go back and make whatever changes that we might need to. I'm interested maybe to see how our tree supports would do here in the model. And overall, there's a lot of additive manufacturing functionality built into Creo that we're taking advantage of. We can get our support built out. We could take it another step forward if we wanted to create and visualize a CLI file for this model, which gives us the slice file needed for printing. We also have the ability to integrate with both plastic and metal 3D printers, so you don't need to have a third-party step to get that 3D print out to the printer. You can save you time, avoid any issues due to data translations within that process. So really everything from the lattice design using our simulation capabilities to figuring out the optimal print orientation to even getting down to generating the supports and sending it out to the printer. We can really get our job done right from within Creo as well. And there you can see our new support structure profile there. Okay, so here we have just about a minute left on the hour, and first and foremost, I want to see if we have any questions, and if not, then I definitely want to say thank you everybody for jumping on today. Again, a ton of different things that we're able to hit on, but really just want to introduce you to the fact that first and foremost, we have a lot of things built into Creo currently to give you what you need to get your job done more efficiently on a day-to-day basis. And even going forward, we're going to continue to improve Creo and continue to invest in these different types of emerging technology going forward.
So it doesn't look like we have any questions, so it's going to pass it over to you, Brittany. Take it away.
Great, thank you. Bear with me, everyone. I am just sharing my screen. Can everyone see it at the moment?
Yes.
Yep.
Okay, great. Okay, so with a minute left here, I'm going to quickly go into our modern packages and what that looks like. Bear with me real quick here. Okay, so we offer 5 new packages. So we created these packages to provide additional functionality, which ultimately increases productivity and efficiency, improve communication and collaboration, as well as quality and competitive differentiation. So we offer 5 packages. What I wanted to show you are our 3 main packages. We created these packages from the feedback from you, our customers. So if you look at the T1 package, this is our base package, and it's pretty robust. It creates the core functionality for engineers to design. After that is our T2 package, which touches on advanced assembly and concurrent engineering, as well as top-down design. And then our T3 package includes a lot of surfacing extensions. We also included some extensions on here that focuses on model-based definition. I know we're at the top of the hour here, so Katrina and I will be reaching out to you individually to show you what this looks like for your company moving forward. So Katrina, I'll hand things over to you to wrap it up and answer any questions.
Great, thanks, Brittany. And thank you also, Paul Sagar and Paul Dye. I'll pause briefly for any questions. While we wait, if you enjoyed the presentation, we encourage you to share the on-demand recording with any colleagues or on your social media platforms. Please also take a second to complete the brief presentation survey. We certainly appreciate the feedback. And keep an eye here. Okay, any questions? Well, as Brittany mentioned, we will be reaching out to you directly, and please don't hesitate to reach out to me as well if you have any questions. We appreciate everyone jumping on. Thank you for giving us an extra 2 minutes, and I hope everyone has a wonderful rest of the day.
Thank you, everyone.
Thank you.
Have a good one.